Hello and welcome back to question 6, part 2 and part 3. Now for part 2, you're given quite a simple question. This is just a 1-mark question. We have to differentiate natural log of x squared plus 1 with respect to x. So I think what most students would do is they'll say that, oh, dy dx is equals to 1 over x squared plus 1 times 2x. And then you'll get this wrong. Do you know why you're getting this wrong? Because nobody said that this is equals to y. If you actually have to differentiate this with respect to x, okay, you actually have to say, I'm going to differentiate this thing with respect to x, right? This is the differentiating operator. ddx tells me that I want to differentiate whatever is on the right with respect to x. I'm going to differentiate this with respect to x, okay? And next, down to the technical details. To differentiate a natural log function, right, we have to pay attention to what's inside here, what I call the argument, the input of the natural log function, right? The input, the argument, goes directly into the denominator. That's it. That's the first thing you need to do. The second thing is, next you need to differentiate this. Differentiating x squared plus 1 gives you 2x. So that is 2x times 1 over x squared plus 1. Then you get 2x over x squared plus 1. Nice and easy, 1 mark. Now let's look at part 3. Part 3 says we have to integrate this thing. Looks familiar? It should, because it's from part 1, and we have actually decomposed this improper rational function in part 1. So I can say that from part 1, this is what I know. Right? To integrate this thing over here is the same as integrating this thing over here, because they are the same thing. And integrating this is much easier than integrating this, because I have seriously no idea how to integrate this if you ask me, right? Except for maybe typing it into Google. So next, let's integrate this one, which is much simpler. So we can see integrating 2 just gives me 2x. Integrating 1 over 2x minus 3, that is natural log of 2x minus 3. You might notice that I have this green bars over there, because technically the answer is half of natural log modulus of 2x minus 3. But you know what? This is not in the syllabus, right? But it will be. I'm assuming most of you will be taking H2 mathematics in junior college. If you do, you have to start getting used to writing modular sign when you integrate. Yeah? So we'll just write a bracket for now. And for the last one, I'm not too sure how to integrate this one, but I can make use of part 2. Part 2 says that, hey, if I were to integrate this, I should get back natural log x squared plus 1. Only problem is I have a 7x. Yeah? This is a 7x. So what I can do is change it to 2x, but make sure that I have some sort of multiplying factor to correct it back. Because 7 over 2 times 2x will give me back 7x. Okay? Then you can see that we have a plus c here, right? And next, integrating this will give me 7 over 2 natural log of x squared plus 1. This result to this is directly from part 2. And I've changed my c to c1 because then it's a new constant. That is the answer for question 6, part 3. So I hope this was helpful, and I'll catch you in the next one.